Hello, good afternoon, students. Um, my name is Jibril Muhammad. I will be taking you through this course, Introduction to Computer Hardware, CMP111. The course title, Introduction to Computer Hardware. So, this is the second chapter of the course. So, these are our learning objectives. At the end of the course, we should be able to explain the central processing unit, explain the primary memory and their types, secondary memory and their types, state the advantages and disadvantages of each of the secondary storage media, describe the motherboard, then describe with examples, input and output devices. So if you're talking about computer hardware, we have to know what is computer architecture. So the computer architecture deals with specifications that contains the details of the various software and hardware components that make up the computer system, as well as how they communicate together in order to bring computer system to life. So when we are talking about the architecture, we are talking about the hardware, the physical, the hardware, you know what is hardware from our previous chapter, the software, and how they communicate to make the system come to life, to make the system work properly. This is what we mean by computer architecture. So the most common type of architecture we have is the von Neumann architecture, which was proposed by a mathematician named John von Neumann in 1945. So the key categories that made up the computer architecture, we have the system design, instruction set architecture, ISA, and the micro architecture. So when we are talking about the system design, this handles all the hardware components of the system. So when we are talking about the hardware design, because we say architecture, it's made up of what? The hardware, the software, and how they communicate. So that is why when they are talking about the categories of the common type of architecture, the von Neumann architecture, they say we have the system design. The system design handles the hardware parts. That is, it handles all the hardware component of the system. Then the instruction set architecture handles the software part of the system. That's why they say the instruction set architecture. This is the programming language of the CPU, which defines the function of the CPU based on the process and the programming, based on the processes and the programming the system can and the programming the system can perform. So we are talking about the hardware because we say computer architecture deals with what? It contains the hardware, software. So the instruction set architecture handles the software parts, that is the short. Then the microarchitecture. The microarchitecture, this also known as the computer organization, is the type of architecture that defines the element of data processing, part, and storage. When we're talking about data processing, we're talking about the ability of the computer to process data, part, and storage as well. So when we're talking about the part, we're talking about the path in which data flow in and out of the computer CPU. So the microarchitecture handles what the flow of data majorly, and it's also uh, check how the ISA function, that is the instruction set architecture. Then this is the diagram of the von Neumann architecture. The inputs here, we are having the inputs unit, then the output unit. So we say von Neumann architecture, this is what hardware and software parts of the comprises of the what hardware, software, and how they function to make the system work properly. So now look at the inputs. The system, we know computer generally is processing data, but it processes the data based on the instruction of the user. So you input your data and it goes into CPU for processing and it goes to the output. So the input and the output here are mostly the hardware and often part of the CPU. So this is the structure of the von Neumann architecture. So talking about the CPU and the architecture, we have to see what computer register is. What is a computer register? Computer register are high-speed memory storage unit that are part of the processor. They are high-speed memory. They are part of the processor. They are high speed because they are very close to the processor. They hold the data when the processor is processing data. The memory that the processor used at that point is called register. The CPU register can be said to be a container that holds either an instruction, an address point, or any kind of data, such as characters and bit sequence. Registers are known by the type of computer memory that can quickly accept and store and transmit data that is immediately needed by the what CPU. It is very close to the CPU, so it is known that the processor of the CPU have easy access to the register. So that is why they say it's the high-speed memory storing unit of the CPU, and it's also part of the processor. So registers are known to be type of computer memory that can quickly accept, store, transmit data that is immediately needed by the CPU. It's very close to the CPU, so when the CPU needs the data, it's supplied by the register. So these are the types of registers, their symbols, number of bits, and their functions. We have like 8 to 9 types of registers here. So the first one is data register, the symbol is DR, the number of bits. You know, the bit is the unit of storage. That is, the unit of storage, the number of bits is 16. We know 16, based on their unit conversion, 16 is 2 bytes. So you have to know it both in bits and bytes. So you need 8 bits make what? 1 byte. So 16 bits, that is 2 bytes. So the data registered, the number of the storage capacity of that register is 2 bytes, and the function, it holds memory operands, and the address register, the symbol AR, the number of bits, which is 12, it holds the address of the memory, the accumulator register, instruction register, program counter, temporary register, input register, output register, with their number of bits and their function. Particularly the function, take note of the function, it's very important. So let's see the functional component of the hardware. When we're talking about the functional hardware component of the hardware, we are talking about those parts, those physical part of, you know what is computer hardware? When we're talking about computer hardware, we are talking about the physical part of the computer that make up the computer configuration, or that make up the computer system in its entirety. So the functional component of the hardware, these are the parts that can be seen, touched, that make up the computer hardware. So the first one is the central processing unit. The central processing unit, you all know, is the hardware. The primary memory, secondary memory, input devices, output devices. So these are the 5 functional, basic functional hardware components. So let's see these functional hardware components one after another. The first one is the central processing unit. The central processing unit, which is also called what? Processor, is a piece of hardware in the computer that carries out the instruction of the computer program. You know that another name for the CPU is what? Processor. Because it is called processor because the CPU is responsible for processing any form of data in the computer system. So that's why another name for the CPU is called the processor. It's a piece of hardware component that carries out the instruction of a computer program. It carries out the instruction. Whatever instruction you ask the computer to perform, that's why the computer on its own does not process any data. The user, because of the interaction, you interact, you give you an instruction, do this, and the computer will do it. So that's why they say it's a piece of hardware in the computer that carries out the instruction of the computer program. It performs basic arithmetic, logical, and input and output operation of the computer system. It carries out, you know, the CPU, it carries out arithmetic and logical operations, and also an input-output operations as well. The CPU is made up of control units, arithmetic and logic unit, as discussed below. So the CPU is made up of what? Control unit and what? Arithmetic and logic unit. These are the parts that made up the CPU. So the control unit is a component of a computer system. Now we are talking about the part that we are talking about sits in CPU, the part that made up the CPU, the control unit and what? Arithmetic and logic unit. So the control unit is a component of the computer central processing unit that directs operation of the processor. but it is on its own, the control unit does not process any data. What we are saying here is the control unit, it controls the operation of the processor. We know the processor is being assigned when a task wants to be performed in the computer. You assign the computer assign processor to perform the task. When you perform the task, next task is coming, the processor will take it. So this movement of the processor, the operation of the processor is being directed by the what control unit, and it also controls the inflow and outflow of data. So because of this, the control unit, we know the control unit on its own does not process any data, but it directs the processor, handles this data, process it, give us output. So the control unit controls the operation of the processor, that is the operation of the CPU. Are we together? Yeah. So then another component of the CPU is the arithmetic and logic unit. The arithmetic and logic unit is responsible for carrying out any arithmetic or logical operation in the computer. We know when we talk about the arithmetic operation, it's like the plus, the minus, multiplication, division, power, all these are arithmetic operations in the computer. And when we talk about the logical operations, that is the true or false, the Boolean operation, the all the logical operations you can think of is being handled by the what ALU. ALU stands for arithmetic and logic operation. ALU execute operation in bits. When we talk about bits, bit is a small unit of computer memory. It's when we talk about bits, we are talking about the binary digits, that is the zeros and one. We all know that computer understand only zeros and one, but because of our translator and our compiler, we can write in high level language, and the compiler and his translator will make it to the language the computer will understand, and we'll see our result in the high level language too. So that's for arithmetic and logic units. So now we are done with one of the basic components of the hardware. Then the next one is the primary memory. The primary memory is also known as the memory of the computer. That is another name for the primary memory. You should all know this. In the case of your objective examinations, you will be asked the primary memory, another name. You can use memory in place of primary memory, as the case may be. So the primary memory is also known as the memory of the computer. It's a storage that is utilized to store data temporarily. According to a computer consists of two primary memory, the read-only memory, which is ROM, and the random access memory, which is RAM. So the primary memory is the memory of the computer that stores data temporarily. Please take note of this, temporarily. So types of RAM, we have the ROM, which is the read-only memory, and the random access memory. The ROM is a memory from which we can read but cannot write. When we say we can read, that is, you can view the content of the memory, but you cannot modify it. It cannot be modified. That is what we mean by we cannot write on it. We cannot write on the word ROM. We can view the content of the ROM, that is, we can read, but we cannot write. That is, we cannot modify the content. That is what we mean by this. This is a memory from which we can read but cannot write. That is, we cannot modify the content. This type of memory is not volatile. What we mean by non-volatile, that is, let's explain volatile. When we say something is volatile, that is, when there is any power interruption, the primary memory, the memory that is volatile, that is the content of that work, the work you are doing, you can lose your work. That is, it does not save your work. That is, it is volatile. That is, you can lose your work if there is any power interruption. That's the case of volatile. So the ROM is not volatile. That is, whether there is power interruption, your work will be there, and you will still find it. Example of this ROM is let's explain this RAM around in a very short form. The RAM, let's say you are typing your work on a Microsoft Word. So the Microsoft Word, as you are typing your work there, you are working on the RAM. You are working on the RAM. But when you save your work, that is, when you don't save it, you are still working on the RAM. So that is why if there is any power interruption, that work you are doing that you did not save, you will lose the work. That is, it is volatile because it is still in primary memory, it is still in RAM. But when you save your work, then the work is in the main memory. Did you get it? All the RAM and the ROM, they are primary memory. They come with the computer. They are pre-installed in the system. Are we together? So now the ROM is not volatile, but the RAM is what volatile. In the case of this Microsoft example we are giving, if you save your work, it is in ROM. But if you didn't save it, as you are typing it, the memory that you are using when you are typing is in RAM. So if there's any power interruption, you cannot find your work is gone. But if you save your work, it is now stored in ROM. That is, it is not volatile. That is what we mean that this non-volatile. And the information stored is stored permanently through pre-installation during the manufacturing process of the computer system. So the ROM and the RAM, they are all there during the pre-installation period. So types of ROM, we have the maxed ROM, the programmable ROM, the erasable and programmable ROM, the electrically erasable and programmable ROM. Then these are the 4 types of ROM we are having. So now the RAM, the second type of primary memory, RAM, random access memory. The RAM is the internal memory of the CPU used for storing data, program, and process result temporarily. So the RAM is processing result temporarily, is storing data temporarily. Are we together? So the RAM is storing data temporarily, just like the example of the Microsoft I gave you. As you are typing your work in the Microsoft Word, the work is in RAM. Before you save it, if you save it, it's going to the ROM. That is, it's now in ROM. That is why even if you off your system and on it back, you can still find the work. But in the case of that RAM, as you are typing, and there's any power interruption, so and your system is desktop, sorry, in the case of laptop, even if there's power interruption, your system can still be on. But in the case of desktop and there's power interruption, your system went off, so your system will go off with the work. So it stores data temporarily. It is a read-write type of memory. Just like the ROM, we say the ROM is only, you can only read, but it's not write. You cannot write on it. That is, you cannot modify the content. But in the case of RAM, you can modify the content and you can view the content. That's why they say it's a read-write type of what? Memory. Look at it here. The read-write type of what? Memory, which stores data while computer is still running. Can you see what we said? In the case of that, just in the example I gave you of Microsoft Word, as the computer is running, you are typing. So you can modify the content. That's what they mean, you can write. And the system is still running. But as soon as the machine is switched off, data is what erased. Can you see? It is not volatile. As soon as the machine is what went off, your data will what go with the power. So that is what RAM. That is the difference between RAM and ROM. So we have types of RAM. We have the dynamic RAM, static random access memory, synchronous dynamic, and DDR, synchronous dynamic RAM. So features of the RAM. What are those features that you see and you know that this thing is a RAM, is a random access memory, closely connected to the processor. They are closely connected to the what? Processor. Then stored data are quickly and easily changed. That's for me that you can what? You can erase them, it can be modified. Data in the ROM can be what? Modified. You can quickly and easily change them because it did not save them to the RAM, to the ROM. Hold the program and data that the processor is actively working on. So it holds the program that the processor is what actively working on. Just the case of the Microsoft Word I gave you, the example of the Microsoft Word, it holds the program that the processor is actively working. As you are typing, the processor is working on the Microsoft Word. So the RAM holds this program that this processor is working on, interact with the processor million times per second. Because of the closeness to the processor, it interacts with the processor million times per second. Needs constant electric power to keep information. You need, RAM is volatile. If there's any power interruption, so it needs constant electric to keep your information. If there's no electric, or if there's any interruption in power supply, then you should know that your work is gone. So the next one is the secondary memory. The secondary memory. Um, we have explained the primary memory. We should know that this primary memory are the memory that are pre-installed, that came with the computer. That is in a layman term. But this secondary memory, they are the external storage that we attach to our computer. External storage was like uh, the DVD, the CD, the flash drive. In the case of your phone, memory card is also an external, is also a external storage, so it's also a secondary memory. So let's see a secondary memory. Secondary memory is a type of computer memory that handles where programs and data are kept on a long-term basis, because you store your program on a long-term basis on the secondary memory. It is usually not non-volatile. It is non-volatile because it doesn't depend on the power supply. Even if there's any power interruption, it still remains there. It cannot, you cannot lose it because it retains its information even when power goes off. Can you see? It is not volatile because it retains its information even when power goes off. It, however, needs power when information needs to be stored into memory or retrieved from it. When you want to store information into the computer, or you want to get information from your external, from your secondary memory, so that is when you need power, and the power is the power of your system, because your system has to be on for you to insert your flash and it will read the content, your flash or your hard drive, before it reads the content, and then you copy it or you put it inside. The most familiar secondary storage devices need constant electric to keep information needed to be stored in the memory or retrieved from it. The hard disks. So the most familiar secondary storage are the what? The hard disk and the what? Optical disk. Hard disk and what? Optical disk. These are the two most familiar secondary storage. So magnetic storage device. We are talking about, we are in the types of secondary storage now. We have the magnetic storage device. This refers to any type of data storage using magnetized medium. Magnetic storage stores data by magnetizing microscopic particles in form of dots in the surface of the watch device. Example of such device are magnetic tapes, hard disks, floppy disks. So these are all magnetic storage devices. Advantage of magnetic storage device: can store large amount of data. We have a hard disk that is up to a terabyte, 500 gigabytes, so and so and so forth. It is not volatile. We all know that it's not volatile. Secondary memory completely is not volatile. It's only the primary memory, which is only the RAM. RAM in the primary memory, but the ROM is also not volatile, and the secondary memory completely is not volatile. It is cheaper compared to RAM storage. So the magnetic storage device, one of the advantages is cheaper compared to the RAM storage. The disadvantage, the major limitation of magnetic storage is that accessing the data can be quite slow because of the size. Maybe before you access the data, you have to, when you put it into the computer has to read the content of that storage device. So it can be slow because of the weight of the device, the external device, which is the secondary memory. As a result, most computer systems use magnetic storage for non-volatile storage of large amount of data, typically in form of what? Hard disk drive. So magnetic storage device, the major disadvantage is that actually it's very slow, and it's because of the content, the size. When something, the size is slow, maybe something of 1 gig, 2 gig to be fast, or something of having a 1 terabyte external storage, and you have documents and whatever folders of let's say 500 gigabytes. So it will take time before it's read all those things. So that is why it's very slow. So the second type of secondary storage is the optical storage devices. The optical storage devices save data in pattern of dots, which can be read using laser beam of light source. What we mean by this is it's it's just like when we're talking about the optical storage device, we're talking about the disk, our disk. No disk, normal CD and DVD disk. Normally they are empty, so you put them inside and inside your this thing and burn them. We burn them to get to put whatever we want to put inside. Somebody can burn it to put his own document assignment. Some people doing movie can burn it and put a movie inside. Somebody can just burn it with a music. So, but it is which is read. You only read. You can only see the content using laser beam source of light, because just like your computer, you have a place where you put your disk. So there is a light there. That light is called the laser beam light source. It's will able to read the dots on that storage device, and it will display the content to you. The data on the storage medium is read by bouncing the laser beam off the surface of the medium. If the beam hits a dot, it is reflected back immediately to how it would be if there were no dot. The dots are usually created using laser beam through the process called burning. We have explained this. Burning, burning is when you are trying to uh, burn a disk to put, when you are trying to convert content into the disk, you try to put something into the disk. So if you have to burn the disk, and when you put the disk, the laser beam source of light will help you to burn the content of the disk. That is, you should put something inside the disk. That is what we mean by this burning. Somebody can burn it and put assignment, and somebody can burn it to put movie, music, whatever, as we explained earlier. Example of these devices are compact disc ROM, CD-ROM, digital DVD-ROM, and we have the remaining devices, example Blu-ray discs, high-density DVD. They all have their own storage capacity. So these are the examples of the optical storage devices. Advantage of these optical storage devices is, one, high data storage capacity compared to floppy disk. Floppy disk is a example of this magnetic storage device. So compared to floppy disk, this optical storage device are having high storage capacity, but not compared to, we have under the first one, we have the this thing, this hard disk. This hard disk is having more storage capacity than this optical, but compared to floppy disk, this optical storage device is having more high storage capacity. They are non-volatile. We all know that secondary memory are not volatile. Random access, that is, you can access them anytime if you want. Disadvantage of this optical storage device is limited in storage size as compared to hard disks. Can you see? Hard disk is having more storage than them. Optical disks require special drives to read and write, to read or write. So it requires special devices. You cannot just put it anywhere. So it requires uh, special drives, just like your CD or your DVD or your laptop or your desktop CD space. So they are only the places that will help you to read the content and to write in the content. So it is easily broken because it's a disk, it's an optical disk. So you can easily break it and it's gone. If you break it, I don't think you can fix it again. If you break it, that is the work, you have lost the work. It is expensive. Yeah, it is expensive, though it's expensive based on the content. It depends if you are having, that's why some movie, the optical discs that are having movies, you can see a movie part 1, 2, 3 that is being sold for 150 or 200, where that is when people are watching this. Then, but there's a software which is also in an optical disc, but the content, because of the importance of that software, it can be sold for 10,000, 20, even 50,000 naira. But when it's just a movie that people are not even interested, you see it 300, 400, and you see, so it's expensive based on what the expenses is based on the what, the content. So the last part of the secondary storage is the USB flash drive. You all know flash drive, normal flash drive. It is called USB because USB stands for Universal Serial Bus. Is a space that is the only space that recognizes that flash drive. That is why it is called USB flash drive. USB flash drives are primarily small external hard drives that do not require external power source to function because they get their own power from the computer in which they are plugged on. So if you plug your flash drive, it doesn't require any power. The power of the computer will help you to read the content of the USB flash drive. They represent a simple, inexpensive way of transferring data from one computer and then accessing it in different computer. You can put data in one computer and you can copy maybe data from one computer to another different computer. USB flash drives use flash memory, which refers to the type of computer technology that stores data and does not require constant power and can be erased electrically and reprogrammed. You can erase the content of your USB flash drive. You can reprogram it, that is, you can format it and reset it in whatever way. So these are the secondary storage device, which we say we have the magnetic storage devices, optical storage devices, and the USB flash drive. These are the three types of the secondary storage device. So let's move to the motherboard. The motherboard, another name for the motherboard is the word circuit board. Circuit board is another name for the motherboard. So let's look at our slide. Knowing that a computer consists of a processor, main memory. When we say, can you see main memory? This is primary memory. I told you another name for primary memory is main memory. Main memory, secondary memory, and sorry, another name for secondary memory I didn't tell you is auxiliary memory. So you can see auxiliary memory or secondary memory, main memory or primary memory. So knowing that a computer consists of a processor, main memory, secondary memory, power supply, and supporting hardware that are housed in a metal case. When we say they are housed, that is, they are being enclosed in a metal case. It is crucial to understand that the components are connected to the main circuit board, known as the motherboard. So all these parts that make up the computer that are being housed in a metal case are being connected to what? A circuit. That circuit is what we refer to as motherboard. So you see that motherboard is just like the mother of the computer. Without the motherboard, the computer cannot function. It's just like the engine of the computer. Because if your computer, you need what? Processor, you need main memory, you need secondary memory, and you need power supply. So all these things are being connected to the motherboard. So without the motherboard, then I don't think without these things the computer will not work. So the motherboard keep these things alive. Most of the components are powered by the what? Power supply unit attached to the motherboard. Various input and output devices are attached through connectors at the rear of the case. The motherboard consists of bus made up of group of wires, which is a pathway for data flowing between components. So data flow between components, that is between different components of the what? Computer. Most devices are connected to the bus through a controller which coordinates the activities of the what? Device with the what? Bus. The processor is an electronic device about 1 inch square that is covered in plastic. That is the processor. Inside the square is an even smaller square silicon containing millions of tiny electric parts. They are explaining most of these. Those are that are into computer hardware. If you open the motherboard, you will see all these things we are explaining. You see the processor, you see the primary, you see the RAM of the computer. So if you open the computer system, all these ones are those that are into computer hardware and computer repairs. Inside the square is even smaller square silicon containing millions of tiny electrical parts. A typical processor may contain about 100 million transistors. That is a typical processor may contain about 100 million transistors. It carries out the fundamental computing within the system and controls all other components. So the motherboard controls the major components of the computer, because if you look at the main memory, the processor, the secondary memory, power supply, I think without this the computer will not work. So that is why the motherboard is very important, and you should know that another name for the motherboard is called circuit board. So the processor is often referred to as what? Central processing unit. I told you earlier, another name for the processor is the central processing unit, or CPU in short. And a particular computer will have a particular type of what? Processor. Different computer have their own different types of what? Processor. Intel and Advanced Micro Device, AMD, are the Intel and AMD, they are the two primary manufacturers of the computer processor, which lead market in terms of speed and high quality. So this Intel and the AMD, most of the computer, you see the processor is either Intel or AMD, that is Advanced Micro Devices. These are the primary manufacturers of microprocessors, that is processor of the computer. And Intel's desktop CPU include Celeron, Pentium, and Core. So you see, these are the what Intel's desktop CPU. While AMD's desktop processor include Cefron, Athlon, and Phenom. Intel makes Celeron M, Pentium M, and Core mobile processors for notebooks. AMD makes mobile version of Cefron and Athlon, as well as a Turing mobile processor, which comes in ultra and dual core versions. So all this, but we should know that the Intel and the what advanced micro devices, AMD, are the two primary manufacturers. These are what they manufacture, the processor, the microprocessors they have manufactured. Features of motherboard. A motherboard comes with the following features. One, it varies greatly in supporting various types of components. It supports a single type of CPU and few types of memories. It support, what you mean that it varies greatly in supporting various type of components. It varies in supporting because of components. If you realize that you put something in the computer and you'll be seeing error or the system will not recognize it. That is, the motherboard is not supporting it. So since the motherboard is not supporting this component, then it cannot. The computer will not support it. Because if the mother chases you away, maybe you love a daughter and the mother doesn't like you, I think you should find a way. Mother, there's no way in. So it supports a single type of CPU and few types of memory. So motherboard usually supports single types of CPU and few types of memory. Video card, hard disk, sound card have to be compatible with the motherboard to function properly. If it's not compatible, it will not function. Motherboard cases and power supplies must be compatible to work properly. We're talking about the compatibility. Everything must be compatible to the motherboard. If not, it will not function properly. And if the motherboard does not function properly, then the system too will not function properly. So input versus output units. The input units, we are talking about the input. When talking about the input units, we are talking about the unit of the computer that sends data to the computer for processing. That is what the input unit is. The unit of the computer that sends data to the computer for processing. It's used in imputing data into the computer. That's why we have the input device. The input unit consists of devices that enables user to enter data into the computer. Input devices interpret the human-like information into form understandable by a computer. In your form, input devices interpret human-like information into a form understandable by a computer. Human-like information, what we mean here is this. You want to write your name, maybe my name is Muhammad, and I wrote MU. That M, the computer does not recognize M. M is a high-level language, and the computer works in bits, binary numbers, zeros and one. So if you write your M, then the processor, the interpreter must, the input device, when you enter this M, the interpreter working with the input device will interpret this M into a form that the computer will understand, some combination of zeros and ones, and it will appear on your screen. But because computer is very fast, as you press M immediately, it will process it fast and it will appear on your screen M. You press, you can use as you are typing, it will be appearing. But there are processes that the letters are undergoing to convert it to binary, and the computer understand it and they bring it to a form that you too will understand it. So all these processes happens behind the scene, and computer is very fast. So you will not even notice, you just think everything is normal, but thank God. Examples of input devices, we have the joystick, keyboard, mouse, joystick, light pen, and the scanner. The keyboard. The keyboard is the most familiar input device. We know, everybody know the keyboard. You know what a keyboard is, which enable the user to input data. You input data in the keyboard by what? Typing. You press the keyboard and your data will be imputed. The layout of the keyboard is like of the traditional typewriter. Yeah, the layout is just like a traditional typewriter, although there are some additional keys provided for performing additional functions. Keyboards have 5 distinct group of keys. So the keyboard is just like a normal typewriter, the traditional typewriter, but the keyboard is having some additional features. There are some keys that were added to the keyboard, which makes it different from the normal traditional typewriter. Let's see this group of keys that were added. This group of keys. So these 5 group of keys that make up the keyboard are: the first one is the standard typewriter key. This one is when we say the standard typewriter key, we mean the normal typewriter. If you know typewriter, the normal typewriter keys, because the keyboard adopted the typewriter keys and added some features, and some keys were added too. So the normal typewriter keys, these are what we call the standard typewriter keys. I think there are the normal keys, the A to Z, the typing keys, and I think maybe a space. If you know typewriter well, very well. Then the function keys. The function keys, these are key from F1. They are mostly at the top of your computer. You see them from F1 to what? F10. And some computer to F12 mostly. So these are the functions keys. Every key has its own particular function. Then the cursor movement key. The cursor movement key are those keys that move your cursor from one direction to another. You have the arrow keys. When we talk about the arrow keys, we mean the up, down, left, right arrow. You see them in your computer. The home key, end key, page up, page down. All these keys move your cursor from one part of your work to another. Then the numeric keys. Numeric keys, these are the numbers, the number keys, the number from 0, 1, 2, 3, 4 to 9. Then the special purpose keys, which is we have the control key, alt, shift, delete, and insert. These are the keys that the categories of group of keys in the keyboard. Then the next one is the next input device is the mouse. The mouse is also known to be pointing device with a cursor control like features. The mouse, you know the mouse, normally we have the mouse, it's having a cursor control like feature, having a small palm sized box with a round ball or light at its base. Yeah, they are just describing the mouse, which sends the movement of the mouse and those transmit corresponding signal to the CPU, which the mouse buttons are pressed. So the mouse just, it's very small. I think we don't have it here, but I'll show you. As the mouse is moving, you all know it's moving. The mouse pointer is also moving towards the direction you move the mouse, and the mouse is having a left click and the right click and the scroll button at the center. This is the computer mouse. You can see it here. This is the diagram of the typical computer mouse. You can see it's like it's divided. Before the up one, the one by your right is your right click. You have your right click. You have your left click. You have your scroll button at the center. So now we have wired mouse and also have wireless mouse. Then the next input device is the joystick. The joystick is a pointing device that is used to move the cursor positions on a monitor screen. The joystick is just a pointing device too. It's used to move the cursor on a monitor screen. You are using it on the screen to move your cursor. It consists of a stick having spherical ball on it. Spherical ball at both lower and upper ends. The lower spherical ball moves in a socket and joystick can be moved in all 4 directions. The function of the joystick is similar to that of a mouse. So it's just like a mouse, but it's used on the screen of the computer. But joystick is primarily used in computer-aided design and also for playing computer games. This is the place we use our joystick, but mostly we don't use it. The primary input device we use mostly in our locality is the monitor, sorry, the keyboard and the mouse. Then the light pen is also uh, an input device. A light pen is a pointing device which is similar to a pen. It is used to select a displayed menu item or draw pictures on the screen of what monitor. It is made up of photocell and an optical system placed on a small tube. If you know that that phone, there is a phone we're using before that you just use it. It has something at the side like a pen. You use it to be operating before we are using our hand. So this is just it's just similar to this light pen which we use on our screen of the computer. Scanner, which is the last input device. A scanner is an input device which works more like a photocopy machine. It is used when some information available on paper is to be transferred to the hard disk of the computer for further processing. So you scan, you know what to mean by scanning. You scan and it appears when whatever you scan will appear on your screen. A scanner captures image from the source, which is then transformed into a digital form. You can use image, the original image can be scanned and it can be transformed into a digital form. That can be stored on the disk. So you have your own document, you scan your documents, the original document, you know, scanner now, you scan your original documents and you save them on your system. So that's what we mean that's stored on the disk. These images can be edited before they are printed. Yes, if you scan anything, you know you can edit it. Yeah, so this is a typical example of a scanner, a very new scanner. So the output unit. The output unit is made up of devices that enable the user to get required information from the computer. Yeah, the output unit is used for displaying of processed results. Normally, when you input a computer in general is an electronic device, accept data. So it accepts data through what? Input device. So when you input the data, then it processes data. Computer processes data. So after processing the data, you need your result. So the result is displayed in your what? Output devices. So output unit is the link between the computer and the user. Yeah, it's the link between the computer and the user. That's like when I'm typing here, if I press letter M will appear. Is that the interaction? Because of the interaction between me, the user, and the what computer. I'm seeing what I'm typing. I type M, I imputed M, and the M display here. I imputed U display here, H, it appears. So the output is just like the output link. It's just like an interface. It's like it acts as an interface between the user of the computer and the computer system. Output devices include monitor, printer, projector, and speaker. So these are the four examples of output devices. The monitor. The monitor, which is primarily called the visual display unit. Another name for the computer monitor is visual display unit, VDU. Take note of this, is very important. Are the main output devices of the computer. Yeah, I'm talking about output devices. The main output device is the what? The monitor. It forms images from tiny dots called pixels that are arranged in a rectangular form. It forms the sharpness of the image depends upon the pixel. There are two kinds of viewing screen as monitor. They include the cathode ray tube (CRT) and the flat panel display. When we talk about the cathode ray tube, we are talking about those monitors with back, something at the back, and we have the flat screen display. So, but mostly any computer nowadays computer, we don't use the CRT, we don't use the cathode ray tube, we use the flat panel display. Don't use that one. That one is outdated, but still there are some monitors like that. And but the sharpness of the image is not as sharp as the upgraded versions of the monitor, which is the flat panel display. cathode ray tube CRT. The cathode ray tube display is made up of small picture elements called pixels. Small picture elements called pixels. The smaller the pixels, the better the image clarity or resolution. So as the smaller the pixel, the clarity of the image increase. So that is why you see some screen, you will be seeing something, the image is not that clear. It's because of the pixel. The pixels are not that small. They are big, a little bit bigger. The smaller the pixels, the better the image clarity or resolution. It takes more than one illuminated pixel to form a whole character, such as later end in the word panel. Some of the disadvantages of this CRT include the size, their size, they are large, just like I told you earlier, they are having something at their back, very big and heavy, and consumes has high power. So it consumes high power, just like the history of computer. If you come computer, there keep a revolution, things are changing. Olden days computer, before you see a computer very big like a house, before you process data, press here, and it consumes a lot of electricity. But there's because of modernization and advancement in technology, things keep going. So just like that, the CRT consumes actually high power. It consumes a lot of power and it's very big compared to the flat screen. So this is an example. As you can see the picture. You have something at the back here. You can see you have something at the back here. It's not flat. Cathode ray tube. So the next one is a flat panel display monitor. The flat panel monitor belongs to a category of video categories that have reduced volume. Can you see? Belongs to a category of video devices that have reduced volume. Can you see? You have reduced the volume, that is the size. You have reduced the weight, the power consumption too, in contrast to the what CRT. You know, CRT is among the disadvantages. So this flat panel display was built based on the disadvantages. Okay, what are the disadvantages of this one? It consumes, it's very big. Then they reduce the size of this flat panel. That is one. And it's very heavy. Okay, they reduce the weight too. Then it consumes a lot of electricity. Then they reduce the consumption of electricity. So they build this one based on the disadvantages of the CRT. You can hang them on wall, can you see? Just like your TV, yeah, just like your TV too. You have smart TVs now, so very flat screen. So is also a flat monitor display. And we have olden days TV, which before you carry it, you must eat very well. So you can hang them on the walls or wear them on your wrist. Can you see? They are very flat and simple. Current uses of flat panel display include calculators, video games, monitors, laptops, computer graphics display monitor. There are two types of flat panel display as discussed below. The first one is the emissive display and the non-emissive display. These are the two types of flat panel display. The emissive display kind of monitors convert electrical energy into light. It converts what electrical energy into light. Example of these are plasma panel and LED television. You know them, the light emitted diodes. So these are the what examples of emissive display. We should know that the emissive display kind of they are the kind of monitors that convert electrical energy into what light. Then the non-emissive displays are kind of monitors that use optical effects to convert light from some other source into graphic pattern, like the fluorescent lights. An example of is the liquid crystal display LCD. So these are the non-emissive display, and is also a type of flat panel display. So this is also a flat screen monitor. If you look at it, is better than and it will have more resolution than the CRT. Then another example of output device is a printer. Printer and output devices which are used to generate and produce hard copy information. You know, printers will produce hard copy information. The information in the system are soft copies. Then you want them on a paper that is hard copy, so you have to print them using your computer, using your printer. By hard copy, it means the information is on paper. We have two types of printer, including impact and non-impact printers. These are the two types of printers we have: impact and non-impact printers. Impact printers are the type of printers that print characters by striking them on ribbon, usually by what? Usually with a what? Hammer, which is then pressed on paper. It's pressed on paper and the ink will just appear to press it on paper when it's printing, and the ink will appear and the document will be printed. Some of the characteristics of impact printers include very low consumable cost, is very low consumable cost, it's very noisy, useful for bulk printing because it's very low cost, because it's very cheap. You can use it to print a bulky, plenty things, as well as there is physical contact with the paper to produce the image. In addition, printers in this category include the following. These are examples of what? Impact printers. The first one is dot matrix printer, daisy wheel, line printers, drum printers, and chain printer. So these are the 5 examples of impact printers. You should take note of them. They're very important, particularly in the case of your examinations. You can also know them for your own good. Yeah. So non-impact printers. This is another type of printer that print characters without using the ribbon hammer like mechanism. It doesn't use that mechanism of using hammer to hit and print. No, these printers print a complete page at a time. It completes page at what? At a time. When you want to print, you send it to an impact printer to print that page at once. Those they are also called page printers because it prints page at once. It is also called page printer. Some of the main characteristics of non-impact printers include: it is very fast than impact printers. They are not noisy. Can you see? High quality. So impact printers have high quality than non-impact printers, and they are more faster. They are not noisy. So, but support many fonts and different character size. So, impact printers support many fonts and character size. Yeah, that is impact printer. So, but compared to the cost, the impact printers actually is more expensive. It's more expensive than non-impact printers. Sorry, the non-impact printer is more expensive than the impact printers, but actually want better job, just use non-impact printers. Despite it's very cost, but it has high quality and there's no noise. Some printers, if you want to print, you'll be hearing the noise and it's disturbing. And it's very fast, it's not slow. Example of non-impact printers, we have the laser printer, inkjet, jets, DexJet, and thermal printers. These are the 4 types of what? Non-impact printers. You can see example of this one. The dot matrix is non-impact, and inkjet printer. You can see them here. So another example of output device, we have the projector. We all know projector. A projector is an output device that is used to represent screen. A projector is just used to copy your screen, to represent your screen, to project your screen, the screen of your computer. Maybe a projector, let's see what the slide is saying. A projector is an output device that is used to present results in the form of soft copy on the computer screen while extended and projected to an external and mostly bigger screen known as what? Projector. So the projector is just a bigger screen that that is used to display the content of your screen. Yeah, this is a projector. You can see the picture there. It's an example of a projector. You just set it to the direction you want it to project, particularly mostly a white very clean white screen so that the content will look very clear, and the screen will be bigger, not like that of your system. Yeah. So the last one is the speaker. The speaker is also an output device. Is referred to as the sound system. The speaker is a hardware device that serves as an output device used mainly to produce sound. The speaker used to produce sound. When you talk to a mic, that is your input. You inputted what, a voice, and the output what will be what, the sound, which is that's what made the speaker an output device. So this is a picture of the speaker, as you can see. So I think we have come to the end of the lecture. Thank you for listening. If you have any question, observation, or suggestion when we upload the material, you make your observation or question, or you make a suggestion to make our lecture more better. So thank you for listening. See you another day. God bless you.